Welcome to the Calculus C section. In this section, we'll be discussing power series. Okay, so we've dealt with sequences and series, but a special case for series is the power series. Now, a power series is any series that can be written in the following form. The sigma from n equals 0 to infinity, Cn times x minus a to the nth power, where a and cn are numbers. So the cn's are coefficients of the series, which can be any scalar, 1, 2, 3, 4, as many as you can think of. It is important to note that in a power series is that a function of x. So in prior we were dealing with series that only contained numeric values. However, now we're going to be dealing with variables to be in the series as well. So for example, we could have something like x. Let's write that more clearly. We can have something like, say, x, maybe 2x, 4x, 8x, 16x, and that would be the components of our series. Obviously, this would be additive or subtractive, and those can now be incorporated in our series rather than just having 1, 2, 3, 4, 5, 6. Okay, so before delving into this topic of power series, it's also important to understand some certain terminology. So we have this thing called R. R is deemed the radius of convergence. So if x, the absolute value of x minus a, is less than r, which is our radius of convergence, then it will converge, which makes sense, right? And then if the opposite is true, if x minus a, the absolute value, is greater than r, then it will diverge. Okay, but as you can notice, these two are both extremes. They don't account for the equal to, but if the absolute value of x minus a is equal to r, then we know that the series, we don't know if the series will converge. It may or may not. We don't know, but we account for this as an unspecified convergence / divergence. So there's nothing denoting whether this can be determined as a convergent series or a divergent series. Additionally, we have an interval of convergence. An interval of convergence. Let me write that this is the radius of convergence, and our interval of convergence is as follows. Interval. If a minus r, our radius in convergence, is less than x, which is less than a plus r, the power series is going to converge. And if x is less than a minus r and x is greater than a plus r, then we know that the power series diverges. These are some interesting scenarios for convergence and divergence. So I hope that helps. If you need more assistance, there's a bunch on the website. Thank you.